what I'm doing yet, but I am starting to record the this class. Now, not you guys, but the class. So what's going to happen this semester is that I can't assume that life isn't going to get crazy and that everyone is going to always be able to come to class, right? There's going to be health problems, there's going to be internet problems, there's going to be all kinds of things. So now more than ever, I think it's important to be flexible. So even though we're meeting synchronously, I am going to be recording the class and streaming the recordings to YouTube. So what will be recorded is my audio and the screen share. So let me go ahead and get that started so that you can see what I am looking at as well. Screen 2, and I am looking at the website for the course. Does everybody have that in front of them? Got it? All right. So yes. So that way, if you're not able to be here, you can see and hear what you missed. However, to protect your guys' privacy, the way that I have set up this recording is that what's being captured is on the monitor that is to the left, not the Zoom window. So I've got a 2 monitor setup. That way your audio and your video will not be recorded. So using the chat window is good to catch my attention. You can interrupt me at any point, and I just have to try to remember to review the questions. That way folks who are listening to the recording will know what you asked. This morning I tried to play with the polling option and I was unable to get it to work. So we're not going to do that. If I have questions to ask you, we'll do it old school. You can wave at me. You can use the icons. Do you guys know how to do the hand signals and whatnot? Can I get a thumbs up if you know how to find those? Oh, yes, there's all the yellow thumbs. Manual thumbs up is fine. That works just fine. Yellow thumbs ups otherwise. Yep. Okay, good. You can also raise your hand in that same window. If you have something to say and you don't see me stopping anytime soon, you can get my attention that way, hopefully. And if you want to send an anonymous note on the chat window, I just wanted to point out that option when you type. There's a drop-down menu that says everyone or just a specific person or just me. So if you want to ask a question, but you're afraid to look stupid in front of other people, I know that happens sometimes that you feel that way. You can just ask it anonymously. So, all right. So I have for you the website. So all course materials for the semester are going to be on this website. That way they're freely accessible from outside icon. That way I can use it for folks outside the class, folks in previous classes, and that kind of thing. The only exception is the readings. The readings I am storing inside the class site on icon because those are copyright materials that I shouldn't be sharing freely since they're not mine. I've had several questions on one point. Let me scroll down on the course website here to where the readings are. This section right here, the Mitchell book, that's the only thing that you could purchase if you want to. You do not need it. For those of you who are in programs where the use of Stata is very prevalent, and one of the things that you're hoping to get out of this course is to become a better Stata user or a beginning Stata user as it will, I like this book. And that's why I recommended it. It's one of those resources that's not just here's the code, but here's the logic behind the code, and sort of it walks you through things from a more conceptual point of view. So I like it, and that's why I have it on here. If you don't need to become a good Stata user, you don't have to spend your money. Okay? Yes, thumbs up on that. All right. Let's see here. The other thing that I have, besides Icon, in terms of getting you course readings and this website to get all of the materials that we'll go over in lecture, is a custom homework system that is not yet live. I am waiting to see how many people drop or add the course before I introduce that, but it is the way that you will be doing homework assignments this semester, so I will make I'll give you more information about that when the time comes. So to keep myself from mumbling too much, I do have a beginning slides of my PowerPoint to try and talk about the course, but just to point out the highlights, we're going to meet together twice a week, 12:30 to 1:45-ish. I have a class right after this that starts at 2 o'clock and goes to 3:15, and then I have office hours from 3:15 to 4:45. So this meeting room is just going to stay open the whole time. You can leave and come back if you'd like to come to office hours. The way that office hours are going to work is that I will admit all of you basically who want to come, and you can sit and work on things and pop in for questions if you have questions, and then go back and work on things and come back. That way I can be talking to multiple people at the same time and giving out simultaneous help. So the idea is to be able to be efficient with respect to helping people with assignments or answering questions by having group-based office hours. However, if you'd like to talk to me individually, if you want to talk about things that are related to the class or research that you're working on, office hours are for anything. You can also request an individual appointment. I will warn you, I'm not going to campus. I'm just not. So we will have to do it via phone or via Zoom or some way that's electronic so that we can all stay safe. All right. With me so far? Okay. All right. Then let me see here. Let me grab my PowerPoint, move it back over to that window. Here it is. Double check that my stream is still recording. Yes, all good. All right. By the way, the videos are going to be posted at this course website once I get a chance to do that. So it'll be posted later the same day or the next day. So there'll be a video that directly corresponds to each class period. Alrighty. So we have a PowerPoint because why not? Let me go back to the beginning. All right. Can you all see this? Good. Any questions before we jump in? Nope. Enthusiastic head shaking. Thank you, Pamela. Yes. Yellow thumbs. Very good. Okay. All right. I'm trying to keep an eye on the chat window. If I miss a question, though, please feel free to interrupt me, flag me down. So first off, what to expect? Why are you here? There's two good reasons to this, and either one is equally acceptable to me. One, this class fulfills a requirement. I have a quantitative methods requirement for the college, therefore I am here. If that's the only reason that you're here, I'm cool with that. I hope to convince you otherwise, though, because this is the beginning of what I hope will be something interesting to you because it helps you get better at whatever kind of research you came here to do. We're not going to be learning about statistics. We're learning about quantitative methods. It's all about the focus, right? The idea is to be able to give you a tool set of techniques that help you understand quantitative data, summarize them, try to find patterns in them, draw conclusions about them. That's what this course is going to be about. So we use statistics to try to find salient features of data and to provide reference points for what is expected versus unexpected. But it's all about the use of statistics and not the derivations, right? If you go to the statistics department, they would teach this material very, very differently because they're trying to achieve a different goal. What I'm trying to help you do is to be able to have the confidence to collect quantitative data, to interact with quantitative data, and to pursue a skill set that I believe is an investment in your future. Right now, life is crazy, right? It's hard to stay motivated, at least for me, to write the papers, to do the readings, to do all the things that we need to do when the world is literally on fire, right? I stepped outside yesterday afternoon and I thought someone was blowing off fireworks. And my husband's like, no, that's from California. California is on fire right now. So the metaphor, the world is on fire. No, it actually is. And I understand that it's hard to stay focused, but this material to me is an investment in you. This is a skill set that makes you more employable than you otherwise will be, guaranteed. There are students that I've had from all different programs across different colleges, from psychology, from communications, from education, from political science, sociology. I've known several students who've been able to get jobs just because they got good enough at quantitative methods. So this is something that in addition to whatever you came here for, if you can pick this up, if you can have the courage to dig in and treat this as an investment in yourself, this is something that's going to serve you well. I honestly believe that. So, in terms of expertise, I'm not going to lie to you. You're not going to be able to get everything that you would need to get to that point out of one class. It's just not possible. But I wanted to plant the seed of where you could go. So, at a minimum, if you take this class, you pass, you meet your requirement, you go on, you get your degree, right? That's great. If you're willing to engage past the minimum, and you can, to take other classes, then you can become more able to handle different kinds of research designs. The models that we're going to learn in this class are designed for one particular type of design. They're a starting point. But you can become more flexible in what you know to be able to work with more kinds of quantitative data to become more employable. Um, there's a possibility that if you were willing to take enough classes, you could pick up a master's degree in educational measurement and statistics in addition to your regular PhD coursework. Beyond that, with or without the formal master's, if you take enough classes, you can begin to bill yourself as having a specialization in quantitative methods. So I've met students who have been successful in getting jobs where the ad read things like, we want somebody who has expertise in blah and can teach the stats classes, right? That type of ad is becoming increasingly common. And so just because you came here in a program that's not necessarily focused on measurement, statistics, quantitative methods, that doesn't mean that you're not eligible to join that world and to be able to pick up the skills that make you marketable in that way. So just to plant the seed that even if you're thinking this is a one and done, I'm just going to get out, it doesn't have to be that way if you don't want it to be. So what are we going to do? We're not doing statistics. We're doing applied statistics, and there's a big damn difference. Yeah, I tend to swear a lot, so I'll just apologize for that in advance. I try to keep my swears like PG-13-ish, the occasional F-bomb if it's warranted, but yeah, it is, but there's a big damn difference because a lot of people say, I hated statistics because I don't like math, right? Or I'm bad at math, or I haven't taken calculus in 25 years, right? All of these things. I'll give you my background with respect to this. I was a psychology major when I was 17 years old, and I had taken calculus in high school, and I was able to pass out of math and only take one more course. And so I picked the very easiest math course and I was done because I was going to be a psychologist who helped people. I didn't need math to do that, right? Well, lo and behold, the next year I took the research methods and statistics course in the psych department. That was at the University of Nebraska. And I learned that math had a reason. It wasn't just plug and chug, and here's how you use this formula, and here's how you make this parabola, and here's how you find the limit, and here's how you find the derivative, and all the stuff that I learned how to do but didn't give two shits about, right? I learned that math had a reason, and I just thought that was so cool. So I took all the classes that I could because I just kept going and going, and turns out I wish I had more math because to be able to focus on this entirely, I often hit a ceiling into what I can read on my own because I don't have that training. But it's not about math. You can get good at this stuff even if you haven't had math for a long time because what you need to learn is logic, not math. It's if this is true, then this is what should happen. And there's a very well regimented set of rules that guide decision making with what is reasonable to do with data. Now, just like anything else, the further you get, the more nuance there is, the more gray area there is. But to get started, there's not a lot of math. More importantly, you're not going to do the math. The computer is going to do the math, and you are going to learn to use the computer to make it do your bidding. That's what we're going to do. So I know this class is often a source of anxiety. Anyone want to admit they're feeling a little feeling a little squishy? The several hands? Yes. Yeah, yellow hands and real hands. Yes. By the way, squishy is my word for like uncomfortable in an anxious way. Like when I step on the floor and there's crumbs and my feet crush the crumbs, like that makes me squishy, like I can't handle it. Squishy is how I was feeling today when I was like thinking like, okay, I'm gonna make this the best Zoom class ever. We're gonna do it, right? I wanna set a good tone for the semester, get some because I'm very excited about this. In case you couldn't tell, it doesn't hurt that this is like my third caffeine dose of the day. By the way, pro tip: when you're wearing a microphone, you can't drink your soda because it gets in the way. So I figured this out the last semester that you have to steal a straw from your water bottle. So cheers. Anyway, if you're anxious, I want to tell you it's going to be okay because the things that historically have made folks feel the most anxious, we're just not going to do it that way. So we're not calculating things. You know why? Because computers are better at it. And in the world of quantitative excuse me, there's like this much that you could possibly calculate by hand, even if you wanted to. And the second you step out of this tiny thing, you need computers that have iterative algorithms to find the solutions. It's literally not possible to do it by hand. So we're not going to waste our time cranking out things with a calculator. It's just not a good use of our time. We're also not going to do derivations. You're not going to have to prove why the z distribution follows a z distribution or any of that kind of stuff. That's not a good use of our time because it doesn't help you get better at doing research, which is the goal here. I don't expect you to memorize formulas. We're not doing tests, number one. I don't believe in tests because I don't believe in preparing people to dump their brain for 3 hours and then forget it. So yes, thumbs up to no tests. So you don't have to memorize anything. Any assessment that we're going to do, you're going to be able to do on your own time, at your own pace, and you're going to be able to look stuff up as you go. The idea is that you're building a portfolio of resources that you can take with you at the end of the semester. You're going to have examples of how to do various things that you can draw upon if you come across those things and hopefully in your work. So it's okay to not have everything at the tip of your fingertips. Hopefully you'll have certain mnemonics in your head that say, oh, I remember doing this and I think I need to go look here. Like you'll remember the search terms, but not necessarily every detail about it. It's okay to trust the computer programmers who've made the statistical software that we're going to use to have gotten things right. That is perfectly okay. So what is going to be challenging though, and I'm not going to lie to you, this class is a working memory beast. So working memory, the idea of trying to hold at the same time unfamiliar terminology, both in terms of English, but also in terms of notation. There's going to be Greek letters that you have to hang on to. There's going to be definitions. There's going to be, like I said, written vocabulary, the vocabulary that the software uses, and the vocabulary that I use, right? Trying to hold all of that together is the hard part. So we'll review frequently. And just focus on trying to keep a hold of that as the biggest limit to what you can do. So we're learning language and logic for the process of matching data to research questions to the models that will hopefully answer the questions. That's what we're going to do. Okay, so for those of you who admitted to feeling squishy, does that help at least a little bit? Okay, all right, no calculators, right? No calculators. We don't need them. So what we're going to do, I'm not doing tests. I just don't believe in it. I'm not doing it. Never have. I'm not making you do practice problems or anything else that are by hand. I'm not giving you statistics like here's this, here's this, here's this, here's this. What I hope to be able to do is to tie things together because I think it's easier to pick up new material if you have a place to hang it, right? If you have a structure in your head and you can be like, okay, that goes here, that goes here. So that's what I want to try and spend my time doing. The way that I am going to assess you, though, there's really two things that I'm going to ask you to do in terms of interactive work. One is what I call formative assessments. Icon calls them quizzes, and that's where they will be. But the idea is that about every other week, so there's going to be 6 of them planned once we get going here. So the first few weeks we don't have any. These are going to be big picture questions like define this term or what are the 3 things that you need to know about blah, right? Big picture stuff. The idea is that you should be able to answer this off the top of your head or not, or without a whole lot of digging. If there's questions that you honestly have no clue and you need to go back and read more or look back through the notes, that's what that's for. So it's the idea is to provide a means of structured review in between homeworks, and we will go over the answers in class. So each of these is due on a Monday night. That way I can read your answers that Tuesday morning before class and get a sense of if there's any common misconceptions or common problems or that kind of thing. I will give you 2 points for doing each one. So I'm working on a scale of 0 to 100, by the way. So it's just a straight 100 points possible in the class. I'll give you 2 points for doing each one, and I don't grade for accuracy. So if you write something down and it's a good faith effort, there's your 2 points. You can go back and edit your answers afterwards if you'd like to have a more complete version. And like I said, we'll talk about what the answers would be in class as well. So it's just the idea of structured review. It helps me know if a lot of people had problems with the same topic that I need to hit something differently or again or whatnot. The other thing that you'll be working on is homework. And the kind of homework that I'm going to ask you to do is the type of skill that I want you to be able to use in your PhD coursework. I'm going to give you data sets. I'm going to give you questions, tasks to do. Find out what the mean of this variable is. Find out how this variable is associated with this other variable. Is it a positive association or a negative association? These kinds of questions. And you're going to find the answers using software. I will show you the system that I've developed, but briefly, the homework problems are in two types. So there are, it's an online system, so you'll plug in your answers and you get immediate feedback. One type of question is computational, where there is a number that is an answer, and it's graded up to 2 decimal places for correctness. If you get the right number, it turns green. If you get the wrong number, it turns red. And you can try as many times as it takes to make it green. That way you know that you have found the right answer. The second type of question is interpretation. So I want to also teach you how to write about these techniques, how to write results sections that would be for quantitative methods analyses. And those are going to be something that you don't get feedback on until after you submit the homework. So I'll show you more about that later on. But just to know there's going to be hopefully 6 of these. They're worth 88 points, and so that's the other 12. Last semester, I had to eject one of the homeworks because of the whole COVID shutdown for an extra week. If anything crazy happens, I may choose to eject work. The due dates that I have posted for these things on the syllabus, I promise you that nothing will ever be due sooner than what is posted. But if we need more time to finish talking about something, I may bump it to later. Okay? So the online syllabus will always have the most current schedule of information. I update it daily. The printable syllabus that I link to as a PDF, I don't update. I'll update it a couple of times. That way you have a final version of the course to take with you in case someone wants to know what the syllabus covered. But the online version has always the current schedule. And I tend to send out emails if I change due dates or once assignments are open and able to be done. Okay, questions? No. Okay.
I
Well,
had a
yes. There.
clarification.
Yeah.
So the homework, the computational piece is what's graded ultimately whatever we leave submitted. So if we try multiple times to get it green, that green one is graded, or is it your first try?
Nope. What's green?
Perfect.
Yep.
Thank you.
So you will know that you've gotten at least like any one homework will have not to scare you, but probably somewhere between 60 and 100 individual things that you have to answer. Either a choice you have to make for interpretation or a number. And so once you have all the numbers green, you know you have at least that much right. So that will be roughly half to 2/3 of the point totals for each individual homework.
Great. Thank you.
Sure. Other questions? Am I talking too fast? No, we're okay. All right, let me know if I do. I tend to do that as I get like the caffeine and the amp and the stuff going. So I'll try and take it down a notch. All right, checking on the stream, make sure it's still going. Okay, good. All right, chat window. Okay, nothing new there. All right, good to go. Okay, so my job over Zoom this semester, my job is to provide you with custom lecture materials and examples. I'm trying to give you things that are going to help you in your future lives. So the idea is to give you an example of how you would do this that is hopefully generalizable. I use custom lecture materials because I'm going to be honest with you, I have yet to find a textbook for this course that I like. So there's no stuff that I'm just borrowing from some data bank of slides or any of that stuff because a lot of the books that are out there present statistics in a way that doesn't allow you to grow. Like it's viewed as sort of an endpoint, like here are these techniques and this is all there is. I'm someone who teaches a lot of advanced courses as well. And so when I was planning this course, this is my third time doing it, I tried to view it from the eye of what did I wish people had as a foundation to take these advanced courses and how would I explain things differently? What things would I add or what things would I remove? So really the lecture materials and examples that I'm giving you is what I expect you to refer to, so to speak. I want you to ask questions. So I thought in planning for this semester, I thought a lot about the choices for how to do this class, right? I could do lectures where I sit there and talk to a blank screen, and then I just post the videos for you. Are those fun to watch? Can I just get a yeah, no, right? Like, and especially for a stats class, it's like, oh, I'm gonna go watch the next stats video, said no one ever, right? I'd rather watch my son play Animal Crossing than watch this. So we already have sort of a content like this is not necessarily compelling content, but watching a video that has no chance for interaction, I just felt would be too boring, quite frankly, for me and probably for you. So I'm making the choice to continue lecturing because you guys are in front of me, right? With the idea that I want you to be able to take advantage of this format to interrupt me. There's nothing that I have to say that I am so sure it is the rightest way to say it that it's not subject to change. And I spent the last several weeks actually restructuring the first couple of lectures based on how things went before to try and make it better. So I welcome your questions. They're not interruptions, they're the point, right? I want us to be able to talk to each other because this is your class. And I was always the person in workshops and classes who would raise my hand like every 5 seconds, like I was that person, right? It's okay to be that person because look, I have a job, right? It worked. So be that person. It won't annoy me, I promise. All right, so please ask questions. Please review the material frequently. Drill yourself on the terminology, the notation, the vocabulary. Flashcards, honestly, just because the working memory part of it is the biggest hurdle. Once you start committing things to memory in terms of the language, then it becomes easier to follow along and add to it. Um, I would like you, if it's possible, to try and practice using your own data. So if you are working with an advisor who has quantitative data, ask them if you can play with it, right? Try to use the techniques that I'm giving you to find descriptive information for those variables or associations in those variables. Playing with that stuff will make it sink in a way that just giving you canned practice assignments never will. If it's data that you are personally caring about that's in your research area, that will help you more than anything else that I can do. In terms of the readings, I'm going to be honest with you, they're totally optional. I don't love the textbook. Do you know why I picked it? Because it was the best one of the ones I reviewed and it was free. Because no, seriously, because your textbook has like 17 versions after yours that people are paying for, and so the earlier versions have been released. I like it better than the others, but I don't love it. So if you're one of those people who likes to commit sort of like the process of sitting down and reading and sort of chewing on something, it may help you, but I don't follow it that closely. I just don't. So you'll see that on the let me go back to 1 second here. You'll see that on the website, next to each topic, there's a list of readings. It's not that I expect you to have read all of those things for that particular class. Instead, the way that I've chunked up the material is in corresponding lectures and examples. So today's just an introduction, which is why I'm starting at 0. I have lecture 1 and example 1 that's starting next. Like here's all of the readings that would go with lecture 1 and example 1. But lecture 1 and example 1 will take, 2 or 3 weeks to go through. So it's like those readings go through that whole span. Then when we get to example 2, those readings will go through that chunk. So you don't need to worry about having them read by a certain time or date. It's not like that. Um, okay, let me go back to where did my PowerPoint go? Still working with the 2 monitor things. Okay. Um, Lastly, don't be afraid to ask for help. There's a rule that my very first stats professor in psychology, so applied stats, told me there's a 15-minute rule. If you're working on homework and you're trying to get the same box to turn green for 15 minutes, you need to stop. No further progress will be made. There is an asymptote, right, of effort, and you will only make yourself more frustrated. If you find yourself trying to ask the Google for help with your homework, right? You start Googling random terms, just stop. Don't Google University. It's a wonderful thing, and I've learned a lot from Google University, but you know what? They pay me. They pay me to do this. And you're paying them for the privilege of being in this class. So you have paid for the right to ask me questions. That is your right. So if you get stuck, don't feel bad. Just say, here's what I'm stuck on, here's what I've tried, and I can usually help you get started in the right direction. So email is fine. I gave you my office number, which is my Skype number. Odds are good you won't catch me on it unless I happen to be right next to my phone and it's not on mute. But I'd say email is probably the easiest way to get hold of me, and office hours as well. So please don't hesitate to reach out if you need help. Software. So there are 8,000 different stats packages. There are pros and cons of all of them. After a lot of deliberation, I have chosen to sponsor 2 different programs for you guys in this class. One of them is SAS. I don't actually know what it stands for. It's just SAS, Statistical Analysis Software. Let's go with that. You can ask the Google about that. The other is Stata. I don't think Stata stands for anything. I think it's just a word. Those are the 2 that I'm going to teach you. The reason that I picked those 2, one is pragmatic. I am a heavy duty SAS user. I grew to love it at the end of my PhD and into my postdoc. I spent like 6 months just teaching myself SAS, and I use it for everything that I teach, as well as for data management. I've picked up enough Stata to be able to teach with it. I learned it in the context of trying to teach multi-level modeling workshops. And there are several departments in the College of Education that are like Stata specific. So any EPLS students in here represent? Anyone? Okay, yeah. You guys need to know Stata. You just do, right? Has anyone told you that yet? No? Okay, well, I'm telling you, Stata is it's a thing, right? Sociology, political science, any discipline that works with very large data sets where you have sampling weights to worry about, that is what Stata was sort of designed for. So a lot of students need to learn Stata anyway. It's a pretty easy package to pick up in terms of the syntax. A lot of people in undergrad get started in SPSS. Any SPSS people in the house? Few people? Okay. I don't hate SPSS necessarily, but it's limited. So if I can give you an analogy, SPSS is like the home improvement section at Target, whereas SAS and Stata is like Home Depot. So if you just need a hammer, like you wanted to hang up a picture and you can't find your hammer and you want to go buy a new hammer, you can go to Walmart, you can go to Target, you could probably even go to Hy-Vee and find a hammer, right? If you just need to get some descriptive information for a variable, you can find that anywhere, even Excel. But SPSS doesn't allow as much room to grow as the other packages. It stops short of where they are. And that's the reason that I don't teach with it. That being said, you can do about 85-90% of what we're going to do with SPSS2. So it's fine. If you want to use that concurrently, I can help you with it. I grew up with it. I'm very facile with it. Any of you do R yet? Anybody? A little bit?
I've done a little bit of R,
A little
yeah.
bit of R. Yeah, me too. I've been dragged kicking and screaming into the R world. R, okay, yeah, Jacqueline says R too. R is taking over the world. It's one of those things that I would encourage you guys to pick up if you're going to spend your time learning packages. It's an important line on your CV. So all of these different packages, if you have on your CV, you should have a section that's called something like technical skills. Do you guys have that yet? If you don't, you need one. Any of these software packages that you know how to use to do quantitative methods, to do any kind of web programming, even Qualtrics counts. Anything that's outside of just like Office and email is a technical skill. And the more of these packages that you list under that section, the more likely it is that somebody will hire you because you know how to use this and that's what they use. So if you're looking for extra things to keep you busy this semester, learning how to do whatever we're talking about in as many packages as possible is something that should pay dividends. R is very popular in part because it's free, but I believe in life that you get what you pay for. R has no quality control. Anybody can create something in R and put it up and say, here's a package that does blah. And it's not necessarily going to be computationally stable or right. So I have not embraced R as much as other people. I can help you find resources to R. There's actually a course that's being offered right now. What is it called? Computer Packages for something or another. It's a PSQF course. It's taught by Brandon LeBeau. It is about R and how to use R. That's an online course. So if you're looking to do R, that class would be great to take concurrently with this one because you'll be learning, there'll be a lot of overlap in the material, but he also focuses more on data management type of things to do in R and documentation. So Farhan, do you have a question?
Yeah, I just wanted to mention that I started that course today, and
Oh,
it's pretty good.
okay.
It has stuff more than just art. So he talks about reproducibility and lots of interesting stuff. So yeah, it's a good course.
Yes,
Check it
GitHub
out.
and all of those other like
Yeah.
sort of like ways of interacting with data and stuff. Yes, thank you for that endorsement. So that's another opportunity to use R. In terms of this course, I don't expect you to pick up both of these packages. I expect you to be able to use one of them. In terms of which one, um, if, if you have, if you anticipate doing quantitative methods in your future work, in your PhD coursework or other research projects, I would talk to your advisors and figure out and see if they have a recommendation as to which one they would prefer. Like I said, EPLS is all about Stata. I know the folks that work at Iowa Testing Program need to learn SAS, for instance. One constraint that used to be relevant, and I'm hoping that it's not relevant anymore, is to where where these programs are available. So the University of Iowa has this thing called Virtual Desktop, and you guys are going to learn how to use it. It's a little slow and a little kludgy, but it's free. And free is a very good thing in this case because it's actually not free. Your tuition and fees have already paid for it. So it's more like taking advantage of the resources that you have paid for. It used to be that Stata was not available off campus. When the shit hit the fan last spring, they changed those rules, and so Stata has been available. I've emailed the tech people, and they've said Stata will continue to be available. So I hope that it is the case that you can use SAS or Stata no matter where you are inside the virtual machine. Um, so either one of those should be fine. Stata also has a student license that you can buy. It's a 6-month license. It's $48. And so last semester there were a number of students who didn't want to fight with the virtual machine or had internet issues, and so they just decided to buy it, and then it was worth that investment. So that's an option to you as well. And like I said, I can help you a little bit of R and SPSS, and M Plus is another package that I use quite a bit. So. Here is my version of which program is better at what for SAS versus Stata. It's my opinion. You can take that for what it's worth. I think they're both things that are relatively easy to step into relative to R. R has a much steeper learning curve, which is another reason why I'm not doing it here. So what are we going to do? So starting off here, just today, this week, and next week, a little bit of terminology about sampling and data. Univariate statistics is the next section. So just how do you describe one variable at a time? How do you take those variable descriptions and see to what extent you can extrapolate from one sample up into a bigger population? Bivariate measures of association. And then from there, what we're going to learn is all of that stuff. So if your advisors asks what I'm going to cover this semester, here's your list of terms that you can give them. We're going to focus on what is known as a general linear model. If you've never heard those terms before, that's totally fine. That's what I expect. But this general umbrella framework has a lot of specific names that go with particular combinations of types of variables. And so under this framework is things like linear regression, multiple linear regression, simple linear regression, analysis of variance, analysis of covariance, and moderation, which is the idea of testing whether the relationship between variables depends on another variable. So do any of these terms ring a bell yet? A few? Okay, if not, that's fine. We will get there. This slide is just for you to look back at the end of the semester and be like, wow, I learned a lot of stuff. Look at all these words that I now have to put on my technical skills section. Because yes, models that you're familiar with, also skills. Following this course, and in case anyone else out there is listening, hello. I've gotten some blowback for what I'm about to say, but I'm going to say it anyway because I speak the truth. There are options for you if you want to continue learning quantitative methods. This course is an acceptable prerequisite for a number of things. I have designed a new course that is designed specifically as a follow-up to where we leave off in this course. I offered it last spring. Hopefully it will come back again within 2 years, if not sooner. It's about generalized linear models. The idea is to be able to take the models that we use in this course and extend them to predicting all different kinds of outcomes. It's a series of content that is really foundational for advanced courses. I also teach quite a few advanced courses that this class would prepare you for. So classes on what's known as multi-level models. Those are models for data that have multiple kinds of sampling. That is very common in education, for instance. If you're sampling students, students tend to be clustered or nested in classrooms. Classrooms are nested within schools. Schools are nested within districts. So the idea that these people are in these clumps changes the way that you have to analyze the data. And so I teach classes about that. Computer packages is another course that you can take either concurrently with this or after this as you wish. Design of experiments is also being offered this semester. It's offered every fall. And if you want help in thinking about what future courses might be useful for you, I'm happy to sit and chat with you about that as well. So this could be the end of the road if you had enough, but it doesn't have to be. Okay, so that's sort of the intro to the class portion of the program. Questions? Okay, am I still on the beach? I've forgotten. Yes, it's waving in the background. Okay. All right.
Lisa, I have a question.
Yes.
Jen.
Janet, hi.
I'm a little maybe okay. Anyways, here's the question: should we have both SAS or Stata, or choose one of them?
At a minimum, choose one. I think picking up both is helpful in the sense that it allows you to become more facile with the material. So it's like if have you ever tried to learn a foreign language?
English is my foreign language.
Okay, touche. She's like, I'm talking in it right now. Well, I don't know about you, but when I tried to pick up Spanish, right? I actually minored in it in college, and there were certain constructions like when you were learning like this is progressive and this is future progressive and this is I will have had done this. Like when you had to learn how to translate those ideas, it helped me learn English better because I had a structure to it. And so, from the perspective of generalizability, if you have the time to try and pick up both, I think it helps the generalizability because then it's like, okay, I just need to do X. How do I do X in SAS? Now, how do I do X in Stata? And when you figure out a way to do X in multiple cases. If you encounter a third case, then it's like it's easier to do X because X has a more solid foundation. So you don't have to, obviously. Just picking up one is enough because it allows you then to have a tool that you can work with. But there's always, if you take further courses, there's always things that any one package can or can't do that causes you to have to move to a different package. And so having experience with that from the get-go may help that transition.
Thank you.
Sure. Others. Okay. Then, what are we going to do? So, start with some vocabulary. So, what do we collect quantitative data for, right? Big picture. Any one study can't answer all the questions. So, you have to make limiting choices as to what you can do and hope still that you can draw conclusions that are going to mean something. So, in thinking about the realm of data, like who are you trying to talk about? The biggest level you can think about is what's known in stats terms as a population, right? Who are we trying to make inferences about? If I want to, talk about anxiety in graduate students, right? Okay, there's a lot of things like all graduate students with particular life circumstances, graduate students in all programs from all universities, from all countries. Like where's the scope that I'm going at here? So that's something that you would want to think about in advance. And then on the ground, it's like, okay, how am I going to be able to talk about that as a bigger picture idea? Who am I going to get data for? And who you get data for is known as a sample. And the kind of data that you get are variables. They are characteristics of people that differ from one another. So I contrast variable versus constant, right? A constant is a term for a piece of information that does not change across people. A variable is something that differs. So um, in terms of how the data are typically stored, if you see a data set, you'll have columns of information, and typically each person is in a different row. Those columns are known as variables. They're pieces of information that vary across persons, that differ across persons. So in terms of sampling, there's a lot of choices that one would have to make, and those choices have implications for how you would then treat the data that follow, the variables that follow. So for instance, if I want to examine graduate student life, I want to collect self-report information about what program a particular student is from, their levels of stress, and their well-being. And I want to look at some type of associations between these things. So what kind of sampling? Let's say that I want to limit the focus. I'm only going to focus on students from, say, my program, Educational Measurement and Statistics. Well, if I do that, then that's advantageous in that I've controlled for program, right? Differences between programs can no longer be a reason behind anything that I'm going to say. But at the same time, I've limited what I can say to just that particular type of program. So program would be a constant and not a variable in that case. If I didn't want to make that choice, if I wanted to be able to extend what I'm talking about, generalize my results to students of different programs, then I need to sample different programs from the same college at a minimum. But if I want to extend my generalizability, so the idea of being able to talk more broadly about a phenomenon, then to multiple colleges, is that enough? Or should I go to multiple universities? That's a question. In terms of trying to capture the life of an individual student, do I give them one survey and call it good? Well, what happens if they were just having a bad day that day or a good day that day, right? Is that a good enough snapshot of their life? Should I survey them multiple times? There is a trend now that's very popular in psychology and other sciences on that side of the fence known as intensive longitudinal data, where they make people answer questions on their phones several times a day for several days in a row to try and get a better sense of what people's general life is. Yeah, some of you are like, really? No, they pay them. You see, they're very motivated to be accurate and thoughtful because they're paid. That's how it works. No problem. But then you'd have to decide how many times, how frequently, etc. Do you trust each student to be accurate? Would it also help to get corresponding information from their partners, their families, their advisors, their peers. So all of these questions about how to collect your data, I can characterize as whether you want to have an independent sample or you've accepted on purpose some kind of dependency or dependent samples. Dependent means related. In each of these instances, there is relationships among the different pieces of data to be collected. So independent versus dependent samples. An independent sample would be if I sampled each person once from the same program. So program is a constant, and each person contributes one piece of information per variable. It's an independent sample. Examples of dependent samples are far more common. They're a lot more interesting, to be honest. So if I sample multiple programs from the same university, well, students who are part of the same program are more likely to be related in the variables collected than students from different programs. So they're not independent, they're dependent, meaning they're related to each other. And my model has to account for that. That has to be part of my analysis plan. This type of relationship in which you sample people from the same set of naturally occurring groups is what's known as a clustered sample or as nested data. So if you have students from the same school, you have patients who go to the same hospital or clinic, you have employees who work at the same place, like studies where you're sampling individuals, but individuals happen within groups that you can't ignore. That's known as cluster data. It's a particular type of dependent sample. If you're sampling each person more than once, so you're over multiple occasions, which is known as repeated measures or longitudinal data, that's one of my primary research areas. If you're sampling multiple people about the same person, so what's known as, for instance, dyadic data is when you would ask pairs of people, so mother and child, partners, spouses, that kind of thing, about each other and about themselves. That's known as dyadic. So all of these types of samples are what's known as dependent samples. Why I'm telling you this is to set up an expectation as to what we can learn in one semester and what we can't. The stuff that I'm going to teach you this semester is designed for independent samples, where you have people who are not more related to each other than expected, right? They're just separate people and that's it. That requires what's known as univariate models because each person contributes one value of the variables under study, one value per person. Now, if you have research in your future that looks more like what I was just describing, the dependent samples, come back. Come back to my other courses. They're actually focused all about analyses of dependent samples. So the new course, the generalized models, is getting into models for multiple outcomes at the same time, which works for repeated measures as well as other kinds of variables and what we'll cover. I'm teaching a longitudinal course in the spring that is for people who are measured repeatedly over time with the idea of characterizing change. Clustered multi-levels is for the situations where people are nested in groups. So just to put a pin in this, there are ways of addressing those kinds of data sets, but we're not going to get there in one semester. So the good news is that everything that we will get to this semester is a building block. You'll have to take whatever you did this semester and add stuff to it to make it work for dependent samples. So we're doing independent samples for the most part here. So kinds of variables that you might collect. Yes, before? Question, Farhan.
Just in case, I hope I wasn't interrupting. Should I save my questions for later, next time?
Incorrect. You should not save your questions. You should interrupt.
Great. So yeah, I have a bit of a confusion about the example about independent samples.
Yes.
That was in the previous slide. Yeah.
Let's go back.
Before this one.
There it is. Okay.
Yeah, if we're sampling from, I think, yeah, this is the one. If we're sampling from one program, do you mean one specific program?
Yes.
Or one type of program from any university or school anywhere?
Good question. The way that I had intended it was one program, meaning literally one program at one university. If
Yeah,
you wanted to say like students who were in a statistics program here or at Iowa State or at wherever, then I would think of that as a variable instead, because then it's like what university is your program in? And it would still be the case that students who are at the same program and the same university may be more alike than students who go to different universities, even though program is the same.
got it. But wouldn't their scores be like maybe dependent? Because maybe they know each other, maybe they've talked to each other.
Could
So,
be. Could be. Yeah. The good news is that whether or not you have patterns of dependency or relationship because of your sampling is always an empirical question. There are ways of detecting that and quantifying that.
right.
So it's
So
just,
in the yeah, so in the dependent samples example, what you meant to say was that when you're sampling from different programs, some programs will be more dependent than others. So there's a difference in dependency.
that could be true, although that wasn't where I was going. I was just thinking
Right.
that there is a dependency. So,
Good.
like, if some programs have more requirements or requirements that are different, right? The students from that program may be more alike because they share this common experience.
Okay.
And so the students are not independent, they're dependent in the sense that those who have that common root, so students who have the same teacher, students who have the same program, like you can think of them a million different ways, but that's just presence of dependency. I just wanted to sort of highlight that there are models for those situations, but what I'm going to do this semester is not sufficient for those
Got it.
situations.
Okay. Thank
Yep.
you.
Thanks for the question. All right, other questions? All right, let's see then. We were back here. All right, so where are we headed? The rest of this lecture is terminology, describing kinds of variables that you will come across in dealing with quantitative data. Big picture, there's only two kinds. There's categorical and there's quantitative, and everything else is some subversion of each of those. I have a few slides about managing data because that's something that I find doesn't get taught otherwise, and so I wanted to give you a little bit of help with that. The next section of the course is about univariate analysis, so how to just summarize one variable at a time, what's important, and then how to take those summaries and try to extrapolate to a bigger picture population. Bivariate analysis in lecture 2, and that will take us through about the halfway point of the semester-ish, week 6, 7, somewhere in there. So, all right, so types of variables that you're going to come across. What type of variable that you are dealing with is like the first like decision point in terms of your if this then that logic tree here. All variables in your data set, you want to think about ahead of time, recognize what kind they are. And so these are typically decisions that get made when collecting the data. How are you going to measure a particular thing? One main type of variable here is categorical. So I should say that this discussion follows loosely levels of measurement as it's taught in traditional stats classes, but I'm approaching it more from a modeling perspective. Like, what do you do with this information? So a categorical variable, in my definition, is a variable in which you may have numbers stored for people, but they're not numbers. They're labels. Like circle 1 if you are a US resident, and circle 2 if you're this, and circle 3 if you're that, right? 1, 2, 3 aren't numbers. They're just labels. You could switch the order around and it wouldn't make any difference. They're just categories. Binary is one type of categorical variable. That's when there's only two choices. It's also known as dichotomous. That's a synonym. So for instance, are you dead or alive? There's no middle ground there. Are you pregnant or not? Sort of a classic joke. You can't be a little bit pregnant. You just can't. Although, having been pregnant, I can tell you that there's times when you feel more pregnant. I hated life after about 7.5 months or so. That I was just like done, like get out, I'm done, get out. But um, but at the end of the day, right, you're pregnant or not. It is. You can choose to try to measure the variable in some other way, but like you can't introduce more information than there is. That's the idea here. So nominal is a type of variable that has 3 or more categories, but there's no ordering to them. So what is your favorite type of pet? What's your favorite type of ice cream? What degree program are you from? What state did you grow up in? Right? These are nominal variables. I could put numbers on them. I could be like, well, I was born in Missouri and that's a 1, and then I moved to Iowa and that's a 2, and then I lived in Nebraska and that's a 3. I'm making the rounds here, all the way around the Midwestern rectangular states, but the numbers don't mean anything. The last one under this umbrella, categorical, ordinal. These are very common in self-report variables, where there's choices, they're ordered. You want to think they're numbers, but they're not really. So attitude measures, how much do you agree with this statement, right? Strongly agree, agree, neutral, disagree, strongly disagree, right? You can call that 1 to 5, right? You could put numbers on there and no one would argue with you that agree is more of an agreement than neutral or disagree, right? It's the distances between that should make you squishy. So I could label that 1, 2, 3, 4, or I could label that 1, 20, 300, 400. Right? They're still ordered, but there's no guarantee that these things are equidistant. They're not really numbers. Spoiler alert, people pretend these are numbers all the time. They're a special category though. Ordinal data. Synonyms. Other words that you will hear people say to go with the idea of a categorical variable. These are also discrete variables. They are qualitative variables, grouping variables, factor variables, and in SAS terminology, they are class variables. All of those words mean the same thing. They're describing a variable where you have kinds, not amounts. The other kind, if it's not a kind, then it's an amount. And so the other broad category, what I would call quantitative. The numbers are actually numbers in this case. There are equal distances, so we're talking interval measurement, in this subcategory that have 1 or more natural boundaries. So for instance, binomial is one kind. If you have the number of occurrences out of a known possible. So the proportion correct on a test, right? The worst you can do is 0 and the best you can do is 100%. You can talk about that as getting like 39 out of 40 correct, or you can talk about that as, 95% out of 100. But there's boundaries, right? You can't go below 0, you can't go above 100. Another type of variable that's quantitative, numbers are numbers, but has a boundary, is a count variable. The number of cigarettes that you smoke in a given day, the number of drinks you've had. Count variables are often bad behaviors, like things that you would be counting. The number of steps you've taken, right? The weekends lately, I feel like I set a personal record for the fewest possible steps on my Fitbit. It's like, oh, my Fitbit's like, are you still alive? Like, just check in because you haven't moved. Have you ever sat somewhere like on your couch for so long that you look back on your sleep log and it actually thought you were asleep? Yep, that happens at least once a week. It's like you were asleep from 5:30 at night to 7:30. It's like, no, nope, nope. I was watching my son play Animal Crossing. That's what I was doing. And you have picked up on my apathy towards this process. I can't wait until he learns how to read so that I don't have to read what the characters are saying to him. Like that's my sole motivation for teaching him how to read. Mommy, what's it say? Mommy, what's it say? Mommy, what's it say? So anyway, count variables. Lots of examples of those. There are special names for count variables that have to do with zeros. If there's no zeros that are possible, that's known as zero truncated. If there's more zeros than expected, that's known as zero inflated. So there are models and distributions and stats that go with all of these different kinds. I'm just trying to give you a sense of labels as to what search words you would look for, so to speak. The other one is unbounded. So these are very rare. They're possible, but they're very rare. They're numbers, variables that are numbers, and there's no boundaries. It could go from zero to negative to positive infinity. That doesn't happen very often. spoiler alert, the models I'm going to teach you assume we have these kinds of variables. Shh, it'll be okay. It has to be plausible, not necessarily hold exactly. So I call these sort of, rather than them being continuous, continue-ish, right? Close enough for government work. All right, so these are examples of that, but I see the clock is ticking here. We'll get to those next time. So big picture, let's see, take-home points from today. My name is Lisa. You can call me Dr. Hoffman if you need to. The only person who calls me that is my dad, and he's being ironic. Like, hello, Dr. Hoffman. Oh, hi, Dad. No, it's just Lisa. It is pronounced Lisa, so there's no Z. It's not Lessa or Lisa. My mom told me that when I was born, I looked like a Lisa, but not the regular kind. That's the story. I think my mom may have had some drugs because she's not normally that creative, but that's my name. So you can call me that. Take home number 2, don't be afraid. This is going to be okay. It's going to be worth the effort because this is a skill set that you're going to acquire. These are lines on your Vita that are going on here just for getting through this. So even if your goal is simply to pass the course so you can graduate, you're going to get more out of it. There is no such thing as an interruption. Please interrupt me. That's why we're doing class in this format rather than me just lecturing to a blank screen and you guys watching it later. Take home number 4, we're going to learn how to analyze data from independent samples. If you need to learn how to analyze data from dependent samples where people are more related because of the way that the clusters that they come from, come back for more classes. That's what I can tell you about that. Okay, did I miss anything? I think those are the highlights. No. Anyone else want to add? No? Okay, before we adjourn, one quick question, just so I can get a sense of my pop culture references for this audience. This is a multiple choice question. The correct answer is Van Halen, Van Hagar, or what? Okay, so I'm going to ask who votes for Van Halen? Couple people. Okay, 4 or 5. Van Hagar? What? No? No Van Hagar fans. Okay, and the third answer, what? What is she even talking about? Oh, my youngins. Okay. So it looks like this class is what we would call a bimodal distribution. There's the Van Halens and the what is she talking about? Okay, that's good to know. I will have to feed you YouTube links whenever I'm referring to something that you may not have heard of. So that is another part of the education you will receive this semester. All right. Anything else before we adjourn? All right. No, thank you guys. Hope to see you Thursday. If you want to chat with me in office hours, I will be here. So, peace out. Bye bye, cute baby. Bye bye, Deborah.